So what might be a good thing to do first before you try to evaluate this?
Right.
Draw the picture. Yeah, there's a couple things you could do first, but I really would like to draw the picture on this. What would be a great first step if we were going to try to draw the picture on this? Yeah, we are drawing the base here. That's exactly what we're sketching here. We know what the height is. This is the height. Great, Z. Right, that's the height. So we're trying to draw this. We're trying to draw this, essentially, right? Yeah, the XY plane, exactly. Good, good. So we have an XY plane. Yay, XY plane. Y, X, just to be clear. What do we do?
Well, it's gonna be
The X goes from 0 to 2.
is that Y?
So we know X goes from 0 to 2. That's correct, but how do we know? Does it go below or above? It's always positive. This is the positive half of it. So we know it's going to go like this, and that's supposed to be a nice circle. I know my drawing is not the best. Correct. There you go. So if you wanted to do this in Cartesian coordinates, it's not that bad. But there you go. There is the base. There's the base you were looking for. We travel through this wonderful world. Always keep this in mind. Always keep that in mind. That's kind of important. Okay. We now know we're looking at a double integral of the square root of r squared, correct? And what does dy dx convert to in polar land? R dr d theta. Yeah, that's super important. R dr d theta. Yay, nice. So now we just need to figure out the limits of integration. That's where it gets a little bit more fun. To pi over 2. That's correct, because as the point travels, we talked about this before, as the point travels along this arc, this theta gets infinitely close to, and then finally gets to pi over 2. You came up with something that seems pretty good. You came up with what? What? Yeah, never forget this. This is what I've seen. I was having flashbacks in my past multi-classes. We'd be wandering around, and then if you just remember the relationships, most things fall directly out. Most things fall directly out. So how can you piece it together here? Is this correct? Is that okay? Okay, nice. What does x equal? So are there any substitutions we can make here at this point? What substitution can we make? We're not done. Stop waving at me. Hold on, yes? X squared and y squared.
What's your identity? Cosine theta equals
Cosine theta is equal to what?
x over r.
X over r. So where did you throw that in?
Into cosine squared.
Yeah. So x squared plus y squared is equal to 4 times. Like this? Okay. So x squared plus y squared is equal to 4x squared over. Okay.
And then you can, you multiply both sides.
4. So it's a circle with radius 2, center at 0. So which half of the circle are we going to be looking at? Both?
Yes, one's the top limit, one's the bottom limit.
Y is between what? Thank you. Y is between 0 and 2, so it must go from 0 to 2. So what are you only looking at? The upper. The upper, the upper, the upper. You say I hate this? Nice. Absolutely, that's great. So is this one a little bit easier to set up? Yeah. So what does that turn into? X squared, what does that turn into when you convert it? R cosine theta times R sine theta? Is that better?
Yeah.
R dr d theta. I hadn't written it all in. I know you guys are impatient. R goes from what? 0 to what? 2. And what's theta go from? 0 to pi. Much nicer. Yes. And what power is R going to be 2? Yes, you can do this out and get something nicer. 0 to 2 of r to the 5th cosine squared theta sine squared theta dr d theta. Square both sides. And then you move it over, and then you know right here, you know that r squared equals x squared plus y squared, and you know that x is equal to r cosine theta. If you do that substitution, look what happens. You end up with 2 cosine theta. So the point is, Tony's method before was he looked at it, it's kind of like the June and Lawrence method, and came up with a great answer that works, right?
Yeah.
If you didn't automatically see what you thought of as the proper answer, here's how you can get it. So make sure you can convert from Cartesian to polar as well as what? Polar to Cartesian. Are there lots of different ways to algebraically do that? Yes. There's lots of different paths you can take. Be careful.